Starting from question number 1. When one of the lamps on a string of lights breaks, the others go out as well. What does this tell you about the way the lamps are connected? If you go through with the statement, children, then
So can I answer?
one of the one of the lamp is broken. Suppose it gets fused. Still other lamps, they are continually glowing. How they are connected? How they are connected means
They,
there are two options. Either they are series or parallel. Yes, please.
they are in series, so if one lamp is removed, others will go out because the circuit is broken.
Others go out. It means that this combination is a series combination. We know in series combination, all components are connected with a single path, and if any one of the component is broken, it's not about that the last component, if the last component is broken and before that all component will work. No, any one of them is broken, is get fused, spoiled, whatever happened with with that component, then the entire circuits won't work. Entire devices, they just get switched off by automatically. So this is a drawback of a series combination. Any other children want to give some other kind of answer? You are most welcome to share your views, children. Now let's move to the question number 2. Give two benefits of connecting lamps to a battery in parallel. Anyone, please. What are the advantage of connecting components in parallel? Yes, Krista, please.
If one bulb or lamp is broken, then it will still work.
Okay, that's the first benefit. Okay, then the second one. Second one, any other children? Tanuj, yeah, please. Anyone?
Sorry. All lamps get full potential difference from the battery, so all of them goes brightly
Yeah.
fully.
Yeah, these 2 points, children, you remember. One, if means in parallel combinations, the bulbs, they work in bulbs, or means any component, they work independently. Means if you want to switch on and off any one, that you can do. And the second point, that in parallel combination, voltage is same. Voltage same across each component. And suppose I have connected 5 or 10 bulbs in parallel combination with the same watt. All bulbs have the same watt power. So in that case, each bulb will glow with the equal brightness, with normal brightness. That's the other benefit of in parallel combination, but that is not the case in series combinations. The brightness reduces in series. Question number 3. Redraw either of the circuits on the left. Redraw either of the circuits on the left, so that it has a single switch which turns both lamps on and off together. Either of the circuit on the left, so that it has a single switch, means you have to redraw which diagram they are talking about. Where is the diagram? Yes, Karthik, please.
So I think we'll connect the switch in this one. The
I think I didn't get your answer. If you want to just a little bit explore.
no, sir. I was saying that near this one, right? Like right next to the X ammeter, next to like the left side of, we can put a switch there. So if we turn that on, both of the lamps will turn. I think.
Anyone other? This diagram, I think they have not mentioned about this diagram. Um, any other children? Actually, basically what they have said here in this question, uh, we have to connect a single switch in such a way that both lamps on and off together. On and off together, this will happen if we connect both of the bulb in series combinations. Am I right, children? If this combination is a series, yeah, 10th class students. If we connect them in series, then we can switch on and off together. Or and if they're talking about this diagram, children, because they have not mentioned about the diagram. They're talking about this diagram, so where can I put a switch? Then I can put a switch here. Maybe at this point, switch can be connected here.
Sir, I meant to that point where you put the first one.
Anirudh, your voice is lagging, your internet connection. Himanshi, what
Sir,
about? Yes, please, Anirudh.
sir, I meant that like at the start of the battery, you can just keep the switch there.
Yeah, if we put switch
So
here,
that
still we can
if
on and
one
off.
goes off,
Yeah, okay. Agree. So now question number 4. This question is about the circuit on the right. Yeah, here they have clearly mentioned that the diagram circuit on the right. The reading on the two of the ammeters are labeled. They have labeled. This is 4 ampere, and current in this ammeter is 2 ampere. Okay. So what are the readings on the ammeter X and Y? Now, children, please find out what is the reading in ammeter X here. How much current is passing through ammeter X?
Sir,
How much current is there in Y? Yes, please.
both are 2 ampere.
How much current in X?
2 ampere.
How much current is in Y?
2.
2. Now, student, listen how you have to find that in what ammeter how much current is there, that you have to follow just a system, a rule that current always start from the battery, from the positive terminal of the battery, and they have given that the total current produced by the battery is 4 ampere. Now, when this 4 ampere current reaches to this junction point, let me write here, this is suppose B point. So at B point, this is called a junction, children. When there are 2 or and 3 or 4 wires, they just intersect or meet. So at this junction point B, so the current has 2 paths to flow. One path to the right side and other path to the along the Y direction, means the Y axis, as per the diagram. So they have said here, out of 4 ampere, 2 ampere current move to the right hand side, means to the ammeter, this emitter, and that will pass to the X. And the remaining current, what is the remaining current? Total current is 4. If 2 ampere is going to this side, children, to the right hand side, so it means the remaining current means 4 minus 2, that is equal to 2 ampere current will pass through the ammeter number Y, and you have to write that answer here. Now in 4B, if the PD across the battery is 6 volt, what is the potential difference across each of the lamp? Yes, children, each of the lamp. Nicolin and Ananya, please tell me, what will be the potential difference across each bulb? Kenneth and Jordan. Pari Pahel. Students, if you will reply, if you respond, then we'll understand that how much you are able to understand here and how I have to teach. How would I know that whether you are able to understand these questions or not? You please say yes, no, Type your answers. Okay, I have seen it. I typed. Okay. Anina said 6 volt. Tanu said 6 volt. Yeah, in parallel combination, children, the voltage remains same. So it means if you have to connect a voltmeter, across this lamp, and you have to connect voltmeter in parallel like this, and that voltmeter will read 6 volt. And similarly, if you want to measure the what about the potential difference, another bulb, so that voltmeter also measure a 6 volt in parallel combination, because voltage remain same across each component in parallel. Thank you, children, for your response. Harshan said 6 volt. Yes, Harshan. Amrit said 6 volt is right. Calista answer is 6 volt right. Anushka, good. Tanu 6. So this is done, children, and please you can note down all this answer in your notebook also. Now, next worksheet we will do. Now, children, in the circuit A on the right hand side, what does the ammeter read? What does the ammeter read, children? Please look to the question. How much current will pass through? Sorry, battery positive here. So current will go along this path. So you have to find out how much current is passing through ammeter A. Tanu said 1.5. Pari said 1.5. Himanshi said 1.5 ampere. Okay, so your answer is 1.5. Let me tell you how to find out that how this is 1.5 current. Whenever you have to find the current passing through the ammeter, means actually basically that the whatever the current is passing through ammeter, that is the current which is produced by the battery of 12 volt. So in that situation, you have to use equation from the Ohm's law, I equal to V upon R, children. And what is the voltage here? That voltage, I see that it is 12 volt. What is R? R means that the total resistance in whatever the circuit diagram is there, whether 2 resistors are there, 3 resistors are there, they are in series and in parallel, you have to find out their equivalent resistance or total resistance. So here these 2 resistors 4 and 4, they are in series combination, and then it will be 4 plus 4 is 8, 4 3s are 4 2s are, if you divide 3 by 2, 1.5. So 1.5 is the right answer. So battery has produced a current of 1.5 ampere, and the same current will pass through the ammeter. Now in B, what is the potential difference across each of the resistor? Now, children, I will take some time in this question because this is an important question. Potential difference across each of the resistor. And I also want to know, children, your answer for question number 1B. What will be the potential difference across each of the resistor? Means here, what is the, if you connect a voltmeter across first resistor, this is V1. If you connect another voltmeter across the second resistor, and let me take V2. Now, children, this is a series combination, and we know in series combination, voltage divide. Series combination resistor are called voltage divider. They divide voltage. Voltage will be different, means potential difference will be different across each resistor in series combination. So what will be value V1 and V2? Now, children, please. Type your answer. Kartikesh, I said 6 in both, I think. Okay. Other children, please. What is the voltage, children? Please type your answer. Pari said 6 volt in both. Himashi said 6 volt in both. Okay. Now, children, your answer is correct. May I know the reason why you have said that the 6 volt is the
Sir,
Yes, cut. Sorry, Anirudh.
So because in a series combination, volt is divided. So since we see that there are two voltmeters,
Mhm.
a voltage will be divided. Since there are 12 volts, 12 divided by 2 is equal to
Okay.
6. So therefore, those two sides will have 6 volts.
Okay. Now, children, listen. Here, the total voltage, this is equal to V1 plus V2. I have told you when we were doing this topic in class. And the total voltage, this will be always equal to the sum of the voltage across each resistor in series combination. And I know that the total voltage is 12. So V1 and V2, the sum of V1 and V2, it must be equal to with the 12. And as you see here that both resistors are having the same value, same resistance are there. If same resistance are there, if same resistance are there, it means equal voltage will drop across each resistor. So you can write here 6 and 6, 6 and 6 volt. But now consider, children, suppose, now remember, if instead of this 4 ohm resistor, if I take, suppose this is a 2 ohm resistor. Now just forget about the 4 ohm resistor. One is 4 ohm and the second resistor is of 2 ohm, children. Now question is, you have to find the V1 and V2 across each resistor. And these type of questions are important, children. And these are the questions where students make mistakes. And I want to clear that, I want to make that how to do this type of question. But first I want to listen from all of you. Tell me your answer, children. How you will divide voltage in this case, and how will you find out this voltage across V1 and V2? Students, I want explanation. I received answer from Karthik Desai, but explanation is important rather than writing just answer. Just little bit info, explanation. Jarvis, I'm not getting any response from you. Are you there? Krisha, you are not typing answer. Yajesh, please involve yourself, children. Please involve yourself, in discussion. Ethan, now listen, let me explain, children, that how to find out that this voltage. Now listen, students, let me explain. There are two methods. Actually, I know two methods. Maybe there are more methods to do this question. So I want to explain both of the methods, which I know, to tell you how to find out voltage across each resistor here. And just wait a minute, students.
So can you see the chat?
You said 2 volt. Okay, actually, I have written here 2 ohm. So I don't know that right answer. What is the right answer? So let me check, children, and then we will see what is the right answer here. We have taken this 4 ohm. Now, what you have to do, children, recall, I have shared some formulas and some equations from my PPT, and I told you that these are the very important equations. If you can recall, in series combination, I have given you one formula, actually two formulas to find the V1 and V2. Let me write that formula. If you have not noted, please note it down it now. R1 divided by R1 plus R2. This entire equation is for finding the potential across any resistor in series. This is applicable only in series combination. Similarly for V2. V2 is equal to V into R2 divided by R1 plus R2. So with the help of this formula, I will first use the same 4 and 4 ohm resistor that, and let me check whether we have getting the same voltage 6 and 6. Then we will go with the one when the one resistance is 4 ohm and other resistances of 2 ohm. So let me check V1 equal to voltage V. What about this V? This V is the total voltage, which is 12 into R1. What is R1? That R1 means the first resistor here. I will take 4 divided by R1 plus R2, 4 plus 4, 8. I'm taking here this both are same resistor. So 4 ones are 4 twos are and 6. So answer is here 6 volt. And if you go with the V2 also with the same way, then you will also get the same voltage. So this is the first method. The second method, children, with the same first method, children, but if I take 2 ohm resistor here, then again V1 is equal to 12, R1 is 4, R1 plus R2, 4 plus 2. Remember, children, I have taken second resistor of 2 ohm. And now in this case, this is equal to 12 multiplied by 4. And in the denominator, this will be 4 plus 2, that is 6, 6 to the 12, and 4 to the 8. Yeah, initially Karthike wrote that it is 8 volt. So now the voltage across this resistor will be 8 volt, children. It is 8 volt here. And now for the second, it is understood that the total voltage is 12 volt. If it is 8 volt, definitely then the voltage across the second resistor will be 4 volt. 4 volt. Even you can apply this formula also. Let me apply this equation. Now V2 is equal to V again 12. What is R2? R2 is 12. In the denominator, R1 plus R2, 4 plus 2, 6. Now 6 to the 12, and then you will find 2 to the 12. So V2 equal, sorry, 2 to the 4, and V2 equal to 4 volt. And then 8 plus 4 is the right answer. So remember, children, these equations are important that to find out answers in exam. Now, what is the second method? Second method is very simple. Second method is very simple. And what is that formula? You have to find the potential here. You have to find the potential here. Suppose V1. And you know the equation from the Ohm's law, V is equal to I multiplied by same current remains here. And let me take this is the R1 because resistance R1, R2 voltage will be different. So I will take the value of the first resistor here. Or apply this formula V1 equal to I into R1. Here the problem is that you need to calculate the total current flowing in the circuit. That's the problem with this question, with this equation, children. If your total current is wrong, your answer will be wrong, your voltage will be wrong. So we have calculated the I. What was the I, Anirudh? 12 divided by 8. Yeah, 1.3 divided 1.5. So here current is 1.5. Yeah. And resistance, if I take this is R1 4, so 1.5 multiplied by 4, this is 6 volt. The same answer, children. And similarly, the same equation you applied with this resistor, I into R2, same current 1.5 multiplied by R, still it is 6 volt. But if I use this 2 ohm resistor, if I take this 2 ohm resistor, so again the current will change, children. First I have to find the total current because I have changed one of the resistance. So the current will change in the circuit. What is the current in that circuit? I equal to 12 volt, V divided by R. Now the total resistance will be 4 plus 2. So this will be 12 divided by 6, and this is 6 ampere. Am I right, children? I is equal to V divided by 6. So now, sorry, what I'm doing calculation. 12 by 6, this is 2 ampere. I think I'm in stress. Extra class stress on weekends. I is equal to 12 divided by 6. So this is 2 ampere. 2 ampere is the current. Now V1 equal to I. I is now, I will take 2 into resistance, 4 resistance. First resistance is 4. 4 to the 8. That's the same voltage. Similarly, V2 equal to 2 into the second resistor is now 2 to the 4. So I have explained, children, both of the methods, and I hope that you are able to do this question correctly in exam. Let us move to the next question now. In circuit B on the right hand side, what does the ammeter read when switch is open? Second A, children. What does the emitter read when the switch is open? Means switch is open means that the switch is off. The second diagram here. Andrew said, sir, we are going to do quiz. Not today, Andrew, that I want to complete these exercise questions. Next time we will do. Karthik has 12. Other children, please type your answers. This bulb is, sorry, this switch is off and open. So it means there won't be, the battery will produce a current, certain currents. And as this path is open, so no current will pass through this path, but current will pass through this path because it is a complete circuit. It is a closed circuit. So what does the emitter read? Emitter I is equal to V divided by R. V is 12, and the resistance, you will take only this resistance. This is 4. 4 3 is 12, 3 ampere. So my answer is 3 ampere. Let me check your answer. 3 ampere. Karthik, 12 is not. So 3 ampere is the answer for this question. Now,
Sir, I got 3.
Yeah, okay, good. What is the current in each of the 4 ohm resistor when the switch is closed? When the switch is closed, children. Current. Now let me close this. You have to find I1, I2. These are also important questions, children. These are the questions that are important, that comes in exam. If you recall, children, I will give you the equation in parallel. In parallel circuit is called current divider circuit. P-R-A-L-L-E-L. Okay, parallel. We have equation, and you note it down, please. I1 equal to, what is the equation? This I1 equal to I. R2 here. You have to take R2, children, here. R2 upon R1 plus R2. And similarly, I2 is equal to I. And R1 you have to take. So please remember here, in case of parallel combination, in the numerator we have resistance R2 first. R1 divided by R1 plus R2 is total current we already calculated. No, we have not calculated the total current. I have to calculate the total current in the circuit. So total current I is equal to, children, V. What is V? 12 volt divided by R divided by total resistance. Now total resistance will be, children, both are in parallel combination. So I have to find the RP also here. I will multiply 4 4 is 16, and I will add them. 4 plus 4 8, 8 to the 16. So total resistance is 2 ohm, and I will write here. So the current passing through in the entire circuit means this emitter will read 6 ampere when both the
6 ampere.
both the
Sir?
resistors are active. Yes.
So I had a question, sir. Won't we apply that formula RP is equal to 1 over R1?
I use the same.
Oh,
If you apply the same, then you will get that the total resistance is 2. So after finding the total resistance, after finding the total current, children, now you apply these equations. You have to find how much current is going through this resistance 4 ohm. What is I1? I1 equal to, what is the total current? Use this equation, children. I is 6 multiplied by R1. No, sorry, not R1, R2. What is R2? Now here both are same. You can take this 4 here. And now divided by R1 plus R2, which is 8. And 4 2s are 8 and 2 3s are. So I1 equal to 3 ampere. Even you can also use, if it is an MCQ question, then children, there is no need to spend a lot of time in calculation, as the total current is 6 ampere and both resistors are of the same value. So it means current equally divided among the two resistors. So 3 ampere will pass through the first resistor and 3 ampere will current pass through the second resistance. But you have to think about that situation, children. If one of the resistors means their value is different. So I'm keeping that factor in mind and I'm trying to explain in that situation how you have to do that question. If the resistance are different, so different current will pass through the across the two resistors. So in that situation, children, you remember these two equations. Let me move ahead, children. I hope that you have noted down these equations and remember this equation. And if you know other method, you can apply, children, because there is not a single method to do this question. There are many methods. So C part, what does the ammeter read? We have done. What is the combined resistance? We have done combined resistance. Which resistor arrangement C or D on the right hand side has the low resistance? And may I know this answer from Abhi Yadav? Abhi and Sidon. Harshan. Yash said D. Okay. Andrew. Kashvi said is it D? Okay. Now, children,
I
that
think it's D.
last time I shared a video, children, and in that video I told you if this is a single resistor, the total resistance is 10 ohm. If you do a calculation, if you apply here, the two resistors are in parallel. So what is the total resistance? 990 into 10 multiply and then add. And if you 990 plus 10 will be 1000. So 10 this cancel, 10 this cancel, 99 by 10, that is equal to 9.9. And then you can see that simply that resistance is less in lower resistance is in circuit D. And that the shortcut, this is the longest method, but the shortcut method is that I told you in the parallel combination, the total resistance, this total RP, is always lesser than the least value of the resistance available in that circuit. So here RP, definitely this RP will be less than this value of 10 ohm. And we have cross verified it also by finding the answer, that is 9.9. So it means here it is 10 ohm. Here the total resistance we are getting 9.9. So remember, children, in parallel combination, the total resistance will always be lesser than the least value of the resistor available in that circuit.
Yes, sir.
And now power questions are also important. We have less than 2 minutes for this meeting, and there is the power questions. Yeah, this one. This one. Now, children, I want to, in the remaining 15 minutes, I want to practice this 1 to 5 questions, and I also made a plan of doing further questions from at the end of this chapter. So let's see how much we can do it in the remaining 15 minutes. Now, children, please join back this meeting. Right now, you may.
Yes, sir.